Jai Hind, ladies and gentlemen. Greetings of the day to each one of you. Aviation Safety India is happy to present before you the second video presentation on global reporting format for runway surface condition. This video will be mainly discussing the practical aspects of global reporting format for runway surface conditions. So here we go. During this presentation, first we shall discuss global reporting format, information flow. Firstly, the airport operator is responsible for monitoring and assessing the runway surface conditions and any changes which takes place in the runway surface conditions. Airport operator is further responsible for runway condition assessment metrics, runway condition code, runway condition report. And from the airport operator, the information flows to the air navigation service provider, that is Aeronautical Information Service, in the form of Temp. Based on the Temp, the ATC sends the information through voice communication and ATIS to dispatchers and pilots. Then pilots are required to generate air report based on the experienced braking and direction control conditions. This ARAP will be transmitted to the Air Traffic Control and Aeronautical Information Service. Air report is also passed to the airport operator for upgrade oblique downgrade the runway condition code. Now we shall have a look at the assessment criteria. Now I will be showing you the two tables. In these tables, the first column represents the runway condition code that is associated with the relevant runway surface description. Based on the type of contaminant on the runway, its depth, and the outside air temperature. A runway condition code is reported based on the assessment of each third of the runway. The direction for lifting the runway thirds shall be in the direction as seen from the lower runway designation number. The second column in assessment criteria describes runway surface conditions and contaminants that are least to most slippery. Starting from top is the least, and as you go down on the bottom to 0 are the runway condition code that is most slippery. And obviously it has a directly relation with the airplane takeoff and landing performance. Contaminants have different effects depending on their depth and outside air temperature. Please keep this in mind. So I'm talking about this table, runway condition assessment metrics, assessment criteria. First is the runway condition code, and second one is the runway surface description. Now if the runway is dry, the runway condition code will be 6. If the runway surface has got frost, is wet, that is, the runway surface is covered by any visible dampness or water up to and including 3 millimeter depth, and depth of slush, dry snow, wet snow is also up to and including 3 mm. So for this runway surface description, runway condition code is 5. Next is the compacted snow and outside air temperature minus 15 degrees centigrade and lower. For this runway surface description, runway condition code is 4. Then if it is a slippery wet runway, dry snow or wet snow any depth on top of compacted snow, dry snow, wet snow more than 3 millimeter depth, compacted snow outside air temperature higher than minus 15 degree centigrade. For this runway surface description, runway condition code will be 3. If there is a more than 3 millimeter depth of standing water or slush, then for this runway surface description, runway condition code will be 2. For ice, runway condition code will be 1. Wet ice, water on top of compacted snow, dry snow or wet snow on top of the ice. The runway condition code will be 0. Now we shall discuss the downgrade assessment criteria as per runway condition assessment matrix. Downgrade assessment criteria provides the assessment criteria allowing the airport operator to further assess the runway and validate the runway condition code. It includes the column to be used by the pilot to rate the estimated airplane braking performance on a given contaminant and estimate a runway braking action category based on 6 descriptions. A report of braking action on the runway by a pilot, providing other pilots with an indication of the degree, oblique, quality of expected braking. The percentage of runway covered by contaminants. If 25% or less area of runway third is wet or covered by contaminant, a runway condition code 6 shall be reported. If the distribution of the contaminant is not uniform, the location of the area that is wet or covered by the contaminant is described in the plain language remarks, part of the situational awareness section of the runway condition. Now we shall have a look at the downgrade assessment criteria under runway condition assessment matrix. First one is the airplane deceleration or direction control observation. Second column, pilot report of runway braking action. Now if braking deceleration is normal, for the wheel braking effort applied and direction control is normal, in this case runway condition code will be 5 and pilot report of runway braking action is good. Now braking deceleration or direction control is between good and medium. For this, runway condition code will be 4 and pilot report of runway braking action will be good to medium. Braking deceleration is noticeably reduced for the wheel braking effort applied or direction control is noticeably reduced. This will have runway condition code 3 and pilot report of runway braking action will be medium. Braking deceleration or direction control is between medium and poor. This will have runway condition code 2 and pilot report of runway braking action will be medium to poor. Braking deceleration is significantly reduced For the wheel braking effort applied, all direction control is significantly reduced. For this, runway condition code will be 1 and pilot report of braking action will be poor. Braking distillation is minimal to non-existent for the wheel braking effort applied, or direction control is uncertain. For this, runway condition code will be 0 and pilot report of runway braking action will be less than poor. Now we shall have a look at the percentage of runway covered by contaminants. First one is assessed percent, next one is reported percent. The two columns. If it is assessed percent is less than 10%, then this will not be reported and NR will be added. If it is 10 to 25%, then reported percent will be 25, whether it is 12, 14, 18, whatever it is. It will be 25, as that will be reported percent. 26 to 50 similarly will be reported as 50%. 51 to 75 will be reported as 75%, and 76 to 100 will be reported as 100%. Now, gentlemen, remember, contamination depth significantly affects aircraft takeoff and landing performance, including its topping capability. Specific contaminants more than 3 millimeter have been found to significantly degrade aircraft takeoff and landing performance. Contamination depth. The depth is reported as a 2 or the 3-digit number representing the assessed depth in millimeters of the contaminant for each runway third. The assessment is based upon an even distribution within the runway thirds as assessed by trained personnel. If measurements are included as part of the assessment process, the reported values are still reported as assessed depths, as the trained personnel have placed a judgment upon the measured depths to be representative for the runway third. Where contaminant depth is not being reported, the operator should indicate that no information exists by entering not required NR. Now we shall talk about runway condition report. The runway condition report consists of two sections. First one is aeroplane takeoff and landing performance calculations. Second is situation awareness of the surface condition on the runway, taxiways, and aprons. Now let's have a look at the airplane performance calculation section. Two columns. First one is information, second one is source. First will be aerodrome location indicator, which is ICAO assigned location indicator. Date and time of assessment will be in UTC. Lower runway designation number, that is actual number of the runway. Runway condition code for each runway third. Assessment based on RCAM and associated procedures. Percentage coverage of contaminants for each runway third. This will be visual observation of each runway third. Then depth of loose contaminant for each runway third. It will be based on visual observation of each runway third. Condition description of for contaminant type for each runway third. This will also be based on visual observation of each runway third. Width of the runway to which runway condition code applies if less than published width. This will be also based on visual observation while at the runway and information from local procedures. This width of the runway, standard width may be 45 meters if only runway condition code has been worked out for 30 meters of the runway. Then you will have to add 30. Now next is the aerodrome location indicator. It is mandatory requirement. It is 4-letter ICAO location indicator in accordance with DOC 7910 location indicators. This is the format, example VIDP for Delhi. Date and time of assessment is also mandatory. Date and time in UTC when the assessment was performed by the trained personnel. This is the format. Example is like 11 September, so 09 for September, 11 the date, and 1357 is the time in UTC. Lower runway designation number, it is also mandatory. A 2 or 3 character number identifying the runway for which the assessment is carried out and reported. This is the format. Example 09 left or 09. Runway condition report. The direction for lifting the runway third shall be in the direction as seen from the lower designation number. Example 552. That means first third of the runway has got runway condition code 5, second also has got runway condition code 5, and third has got runway condition code of 2. Percentage coverage of contaminant for each runway third. It is conditional because it can change a number identifying the percentage coverage. And it is not reported for one runway third if it is dry or covered with less than 10%. The percentages are to be reported in an up to 9-character group separated by a slash for each runway third. Example, first runway third 25, second runway third 50, and third runway third 100. And NR for first runway third, 50 for second runway third, and 100 for runway third. NR if contaminant coverage is less than 10% in the first third. With the uneven distribution of the contaminant, additional information to be given in the plain language remark, part of the situation awareness section of the runway condition report. Where possible, a standardized text should be used. When no information is to be reported, you must insert an R at its relevant position in the message to indicate to the user that no information exists. This is the example NR/50/100. NR if contaminant coverage less than 10% in the first third. Now, depth of loose contaminant, dry snow, wet snow, slush, standing water. For each runway third, these are the only reported. These are conditional. Report for standing water, a 2 or 3-digit number representing the assessed depth of the contaminant for each runway third. When the depth of the contaminants varies significantly within a runway third, additional information is to be given in the plain language remark of the situation awareness section of the runway condition report. Examples are first third 04, next third is 06, and now suddenly in the third has gone to 12. That means there is standing water. So that must be shown, indicated. Condition description for each runway third is mandatory to be reported in capital letters. The condition type is reported by any of the following condition type descriptions for each runway third and separated by an oblique or stroke or slash, like dry, standing water, wet. Example is wet, oblique wet, oblique wet. Width of the runway to which the runway condition code apply. If less than published width, it is optional. A two-digit number representing the width of the cleared runway in meters is to be reflected. Example is 30. That means only 30 meters runway has been cleared. If the cleared runway width is not symmetrical along the center line, additional information is to be given in the plain language remark, part of the situational awareness section of the runway condition report. Now we shall have a look at the runway condition report, situational awareness section. Reduced runway length, we get it through no time. Drifting snow on the runway, visual observation while at the runway. Loose sand on the runway, visual observation while at the runway. Chemical treatment on the runway, non-treatment application, and visual observation of the residual of chemicals on the runway. Snowbanks on the runway, visual observation while at the runway. Snowbanks on the taxiway, this will also be based on visual observation while at the runway. Snowbanks adjacent to the runway, visual observation while at the runway. Taxiway conditions, visual observations, ARAP reported by other airport personnel. Apron conditions, visual observation, ARAP reported by other airport personnel. State approved and published use of measured friction coefficient. They depend on the state set or agreed standard, that is the standard set by our DGCA. Plain language remarks using only allowable character in capital letters. Any additional information, operational and significant information is to be reported. In the situational awareness section, please remember all individual messages in the situational awareness section will end with a full stop sign. This is to distinguish the message from subsequent messages. Reduced runway length. This information is conditional when a NOTAM has been published with a new set of declared distances affecting the landing distance available. Format will be standardized fixed text. This is the format. Example, runway 22 left, landing distance available LDA reduced to 1450. This is how it had to be shown. Loose hand on the runway, this is the format. Example will be runway RWI 02 Romeo, right, loose hand. Chemical treatment on the runway, this is mandatory. This is the format. Example is runway 06 chemically treated. Taxiway conditions optional. This is the format. Example is taxiway Bravo poor. Apron conditions is also optional. Format, this is the format, and example apron north poor. State approved and published use of measured friction coefficient is optional. This is the example functional state set format and associated procedures. Now we shall learn how to prepare RCR. Aerodrome for Delhi, date is 14 March, time 1750 UTC, runway 07. Runway condition code, first third ice, second third slush, third standing water. Coverage, first third 08%, second third 12%, and third 35%. Depth, First third 7 millimeter, second third 5 millimeter, third 8 millimeter. Now the runway condition report. This is the runway divided into three parts. First third, second third, third. Runway 25 and runway 07. So first third, as we told you that these reports are from the low designation number, that is from 07. First third ice, depth 7 millimeter, coverage 0.8%. Second third slush, depth 5 millimeter, coverage 12%. Third standing water, depth is 8 millimeter, coverage 35%. So for this runway condition report will be for Delhi VIDPA ICAO designator, then 14 March 0314. First is the month, then is the date, then the time in UTC 1750. Then runway designation, located designation, that is 07, low designation number. Then runway condition code 622. Why 6? For coverage below 10%, below 25%, it will be shown as 6. Next is 2. For slush and standing water, the runway condition code is 2. The next is below 10%, not required. It just coverage 0.8%, so below 10% not required. Then here the coverage 12%, so 10 to 25% is to be shown as 25. Then here it is 35%. So 35%, that means 26 to 50 have to be reported as 50. So it is 35, so we have to report 50. The next is the depth of the contaminant. First column is not required. Second is 0.5 millimeter. Third is 0.8 millimeter. And first third has got ice / slush / standing water. Runway condition report situated in a section. Plain language remarks using only allowable character in capital letters. It is of course optional. Format. Allowable characters are A to Z. Okay. And digits are 0 to 9. And they are separated by slash or oblique. Now, runway condition report, situation awareness section. This is how the runway condition report is prepared. Like runway 25, LDA, landing distance available 2750. See, between runway and 25 there is a gap. Then again between 25 to LDA is a gap. Then between LDA and 2750 is gap. Then thereafter there is a full stop. Then next is runway 07, drifting snow. Runway 07, loose sand. Runway 07, chemically treated. All messages end with 0, full stop. Runway 07, snow banks. Now, on the left, there are 11 meters. The snow banks are at 11 meters on the left side, and on the right side, 15 meters. FM is from CLE center line. Taxiway Charlie snowbank. Once again, on the left side, snowbanks are at 0.8 meters away. On the right, 0.9 meters from center line. Taxiway Delta snowbank, left 0.6 meters, right 0.7 meters. FM is from CLE center line. Runway 07 adjacent snowbanks. Taxiway Charlie poor. Taxiway Delta poor. April Echo poor. April Romeo poor. So this is how you generate a runway condition report. Now we shall talk about Upgrading oblique downgrading runway condition code. Now, upgrading, downgrading runway condition code can be made when all other observations, experience, and local knowledge indicate to trained aerodrome personnel that the primary assignment of the runway condition code does not reflect the prevailing conditions accurately. Examples of aspects to be considered in assessing the runway slipperiness for the downgrade process. First one is prevailing weather conditions, stable sub-freezing temperature, dynamic conditions, active precipitation. Observation, information and source. Measurements, friction measurements, vehicle behavior, shoe scraping. Experience, local knowledge, and air reports. An assigned runway condition code 543 or 2 shall not be upgraded. Please remember this. Runway condition code 543 and 2 shall not be upgraded. Runway condition code 1 or 0 can be upgraded using the following procedures and shall not be permitted to go beyond a runway condition code 3. So 0 or 1 condition code you cannot upgrade more than runway condition code 3. If a properly operated and calibrated state approved measuring device and all other observations support a higher runway condition code as judged by trained personnel, the decision to upgrade runway condition code 1 or 0 cannot be based upon one assessment method alone. All available means of assessing runway slipperiness are to be used to support the decision to upgrade or downgrade. When runway condition code 1 or 0 is upgraded, the runway surface is to be assessed frequently during the period the higher runway condition code is in effect to ensure that the runway surface condition does not deteriorate below the assigned code. Where available, the pilot reports of runway braking action should be taken into consideration as part of the ongoing monitoring process using the following principle. A pilot report of runway braking action is taken into consideration for downgrading purposes. A pilot report of runway braking action can be used for upgrading purposes only if it is used in combination with other information qualifying for upgrading. Two consecutive pilot reports of runway braking action of poor shall trigger an assessment if an runway condition code of 2 or better has been reported. Less than poor, the information shall be disseminated, a new assessment shall be made, and the suspension of the operation on that runway shall be considered. Final closing of runway condition report. A final closing shall be made stating that runway condition report, the runway is no longer contaminated. When the runway is no longer contaminated, when there is less 10% coverage by any form of visible moisture in the frozen, liquid or damp state. Example, when the runway surface has dried up to such an extent that there is less than 10% visible moisture left, the final runway condition code to be issued would be 6/6/6. Not required, not required, not required. Not required, not required, not required. Dry/dry/dry. Aviation Safety India is indeed grateful to you for sparing your valuable time to watch this video presentation on global reporting format for runway surface conditions. We are sure that with this second video presentation, you will be quite knowledgeable about various aspects of global reporting format for runway surface conditions and will be able to avoid runway excursions. Wishing you all happy safe flying and many happy landings. Jai Hind.